Hello members, it's me again, Duncan Babu, and I'm here to expound or we share knowledge with you. And our basic today, of course, you know it is statistics, and we are going to take it further. Last time we looked at the mean and the mode. Now, since we are in descriptive statistics, we are going to take it further to look at the values such as the variance and the standard deviation. These are the basic descriptive characteristics of statistics that are very eminent, very important, very crucial when it comes to the practical statistics. Remember here, we are now diverting, or we are just expounding from the theoretical values or knowledges that you now acquired via your respective learnings, maybe primary, high school, or air learning, or maybe a researcher, from now the theory, because now you learned more of theory into now the practical. How do you apply mathematics into real world? That is now what we are doing today. Whether you are a doctor, whether you are a mathematician, whether you are a researcher, whether you are a business person, whether you are a tutor, an educator, a lecturer, a mwalimu in primary, a mwalimu in secondary school, when you are aiming higher into mathematics, not from the abstract mathematics into the applied mathematics, you need know these concepts. I know you know more of this, but now let us redo it again and maybe we learn together. Now, we said we are going to start with these values. We have number 1, we end mean. We end number 2 mode. Number 3, today we are going to look at the variance. Then number 4 is the STD. Already we found mean where we got a mean as 100. And how we got it? It was summation of x divided by n. Our n was equivalent to 10. Then our total summation was equivalent to 1000 from the previous dataset. That is what we're going to review. Our mode was 50, which was repeated 4 times. Now, for today, we are going to take it further into variance and standard deviation. Now, today we have variance, which will take us further into the STD. We know that we end mean, which was equivalent to 100. We end data set, and from the previous video or tutorial, our data set was as follows. It was 100, 50, 50, 50, and then it had 95, then 105, then from 105 we end another 105, then we end 300, then we end 95, and then we end 50. We end 10 data sets. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you. And the summation of it all is 1000. So the summation of x is equals to 1000. And n is equivalent to 10. So our mean, which was x bar, is equivalent to summation of x divided by n, which was equivalent to 1000 divided by 10, which gave us 100. That is how we arrived at 100. Thank you. Today we are taking it further, so we are not reviewing at the mean. Now, sorry. We get 105. Then we end 95. Then from there, from 95 we end 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, right. Correct. That is was our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Now, our variance, how is variance calculated? It is calculated by subtracting each value from the mean and then squaring it. It is calculated, the variance is equivalent to summation. I mean, you subtract each value. For example, itakuwa an x minus x bar, then you square. For individual, imoja. For all, it inakuanga ni summation of x minus x bar, then squared. That's the value, that is how you find you divide by n minus 1 because it's sampled population. Now let us now calculate now this one together with you. The first value will be 100. Remember, we're using this formula, x minus x bar, then we square it. Now the first one will be 100, which is a value, minus 100, then you square, we get 0, and the 0 squared is equal to 0. Number 2, we have 50, so it will be 50 minus 100 we squared, which is equals to 50 minus 100 is minus 50. When you square it, we get 2500. We can go further to all the values, number 3, 4, 5, 6, 7, 8, 9, 10, to the last value. So the last value is 50 minus 100 squared is equals to minus 50 still, square it upon 2500. Then number 4 is 50 minus 100, the square is equals to minus 50, you square, you get 2500. Now the third value is 95, so it upon 95 minus 100 squared, this one is 5 squared, 25. The other value is 105. Now this one will be minus 5, in given 105 minus 100, this one is going to give us 5 squared is 25. The next value, remember we have 5 together, so the next value is 105 again, 105 minus 100, and to pair 5 still, when you square it you get 25, we are there. Then this one, we have 300 minus 100, and to pair square, 300 minus 100, and to pair 200. So when you square 200, you get what? 40,000. You can do your math with your calculator. Squared it, and 40,000. Then the other value is 95. 95 minus 100, in a compare minus 5. When you square, you get 25. Then the last value is 50 minus 100. You square it, you get minus 50. You square it, you get 2500. Now you have now found the x minus x bar and squared. Now we need not to sum it. Remember our formula was the summation of x minus x bar squared divided by n minus 1 for us to find the variance. Now we return the values. I hope you have gotten the concept behind this. So we had the 0. So the summation of x minus x bar squared will be equivalent to, we have 0, that value is gone, plus 2500, that is gone, plus 2500, plus that is gone, 2500, plus we have 3 here, 25 plus 25 plus 25, I mean 25 is 1, 2, 3, yeah, right? Plus 40,000 plus 25 plus 2500. Do away with these ones. Our total value should be 10. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are correct. When you add these ones, let me use my calculator. It will be 0 plus 2500 plus 2500 plus 2500 plus 25 plus 25 plus 25 again plus 40,000 plus 25 then plus 2500. When you add this one, it is giving me 50,100. Now our n minus 1 will be equals to, remember our n was equals to 10, so this implies that it is 10 minus 1, which is equals to 9. Now our variance will be, variance is equal to the summation of x minus bar squared divided by n minus 1. This one is going to give us 50,100 divided by 9, or rather we say 10 minus 1, which is giving us 5100 divided by 9. What do you get? This is the variance. Divide by 9. Now we are going to get 5000. So our variance x minus x summation bar squared is equals to now divided by n minus 1 is equals to 5100 divided by 5100, I mean 10 minus 1, which is equals to 5100 divided by 9. This is what we got, eh? Now, and it was our variance. So it will be equals to 5100 divided by 9, and our variance will be equals to, when you divide this using a calculator, you get 5566.666 na kuendelea. So to round off it will be equivalent to 5566.67. That is our variance. That is our variance. Now we compute the standard deviation. The standard deviation. As you all know, STD is equivalent to the root of variance. I hope you can get that point. This is a formula. So, and we have the variance, but variance is equivalent to 5,566.67. Now, what is our standard deviation? We just replace values. So STD is equivalent to the root of 5,566.67, and our STD will be equivalent to, you find the root of the value. It is 74.61009. Now, we found our variance as this one, and our standard deviation is this one. The last value of the standard deviation that you have got is as a result of the auxiliary values. When you check at our data set, tulikuwa na difference. Tulikuwa na 100, we end 50, 50, 50, then 95, then 300, we end 95 again, we end 50. 1, 2, 3, 4, 5, 6, 7, 8. We end, I'm talking of 300, oh, and 105, 2 105s, yeah. 105 and 105. You realize that the smallest value is 50, and the highest value in our data set is 300, which is here. There is a very big gap between the two, of around the 250 when you calculate. That is 300 minus the 50. And by the way, that is what is used to compute the range. Range is equals to the maximum minus the minimum. So our range is equivalent to 300 minus 50, which is going to give us 250. So the difference between the two is very large. And that is the reason why our variance is large, our standard deviation is large, despite our values being minimum, being just bare 10 data sets. Thank you. We will take it further so that you can now apply it in real life. I appreciate and thank you. Bye.